Let's get right into it. Number 1. Einstein's mass-energy equivalence. Imagine if your bathroom scale suddenly shouted, "You've got so much energy, babe." That's basically what Einstein's most famous brainchild does. The equation E equals mc squared, energy equals mass times the speed of light squared, isn't just a nerdy tattoo or a physics meme. It's the entire reason stars shine, bombs go boom, and your atoms are secretly loaded with cosmic firepower. Here's the deal. E is energy, m is mass, and c is the speed of light, which for the record is about 299 million meters per second. Now square that monster of a number and suddenly mass becomes a nuclear jackpot. Even a paperclip contains enough potential energy to nuke a small city. If only you knew how to unlock it. Don't try. Einstein cooked this up in 1905 while having a chill moment, redefining the fabric of reality. This little equation laid the groundwork for nuclear power, atomic weapons, and your high school meltdown in physics class. It revealed that mass and energy are basically the same thing in different outfits. Mass is just energy that decided to settle down and commit. So next time you look at a rock, a donut, or your left pinky toe, remember? It's quietly vibrating with enough energy to scare a physicist. Or at least mildly impress them at a party. Number 2. Newton's second law of motion. Ready for a wild ride? Because the next star of this brain-melting countdown is F equals ma. Force equals mass times acceleration. Sounds tame, right? Like something you scribbled in a notebook and promptly forgot. But nope. This one runs the entire motion show, and without it you'd be floating uselessly in space like a sad balloon. Newton's second law is basically the reason anything ever moves with purpose. You want to push a sofa? The force you use is equal to how heavy that sofa is, times how quickly you want it to go flying across the room. The beauty of this equation is that it's sneakily everywhere. Cars accelerating, force, rockets launching, megaforce. Your cat launching off the couch at 3 a.m.? Domestic feline force, also known as Newtonian chaos. And here's the kicker. This formula is why physics simulations in video games don't look like stick figures sliding around on ice. It's the blueprint for building rockets, bridges, robots, and regrettable gym injuries. Without it, your world would be frozen in a sad, unmoving montage. Basically, F equals ma is the universal law of how hard you yeet something. Number 3. The second law of thermodynamics. Alright, this next one is the physics equivalent of a reality check. Delta S is greater than or equal to 0. Or in words, the change in entropy is always greater than or equal to 0. In plain human language, chaos is always increasing. Welcome to the party, the ice cream is melting. Entropy is a measure of disorder. And the second law of thermodynamics says that when any closed system, that disorder only goes up. It's like your bedroom. No matter how hard you clean, entropy sneaks in and throws your socks everywhere again. This equation is why you can't untoast toast. Why your coffee gets cold. Why aging happens. Why every sci-fi dream of reversing time gets side-eyed by science with a, yeah, no. You know what's worse? Entropy isn't just passive. It's relentless. Even when you clean, you're just moving disorder somewhere else. You're fighting a losing battle against the universe's desire to be messy. The universe is basically a chaotic toddler with unlimited time and energy. So while this might sound depressing, it's actually kind of liberating. You're not messy, you're thermodynamically compliant. Number 4, Maxwell's equations. Ever wonder how light, radio waves, and microwaves all coexist like one big dysfunctional family? Enter James Clerk Maxwell and his brainchild, the Maxwell equations. These are technically a set of 4 equations, but we're cheating and calling it one item because physics does it too. Maxwell's equations are like the group chat of electric and magnetic fields, constantly whispering updates to each other. In essence, they explain how changing electric fields create magnetic fields and vice versa. This back and forth is what gives birth to electromagnetic waves, aka light, Wi-Fi, your microwave dinner, and that one kid in school who swore he could hear radio stations through his braces. And if you must know what's in the group chat, Gauss's law says electric charges create electric fields. Gauss's law for magnetism says no, you can't have a magnet with just one pole. Faraday's law says moving magnets make electricity. And Ampere-Maxwell's law says moving electricity makes magnets. Yup, your appliances are basically powered by an infinite tag team loop. In more human words, they describe how light travels without needing air or a medium. Light doesn't ride a wave through something. It is the wave. Electromagnetic fields doing a cosmic tango at the speed of light. Without Maxwell, there'd be no GPS, no radio, no internet, no TikTok. Actually, maybe that last one wouldn't be a total loss. Thanks to these equations, you can heat a burrito, send a meme, and tan horribly, all with the same type of wave.
What's that? Is that hyperpigmentation?
Number 5, the Schrödinger equation. All right, now we're going quantum. And things are about to get weird. The equation here? IH bar d psi by dt equals h psi, also known as the Schrödinger equation. And no, it's not a Harry Potter spell, but it is the reason quantum physics exists, which means it's also the reason your chemistry teacher cried in college. This deceptively short equation is what lets us describe the behavior of particles that don't really behave. It's the math that powers quantum mechanics, the science that says particles can be in multiple states at once, aka the universe's official maybe button. In Schrödinger's world, a particle isn't just here or there. It's described by something called a wave function, which tells you the probability of finding it somewhere, sort of like a cosmic game of hide and seek, where the particle is both hiding and seeking itself. This is also where that infamous cat comes in. According to the Schrödinger equation, if you don't look in the box, the cat is both alive and dead. Not metaphorically, mathematically. And yeah, it's upsetting. But quantum physics isn't just cat memes and philosophical dread. It gave us lasers, MRI machines, semiconductors, and the ability to binge-watch reality TV on your phone. So, Schrödinger's equation, totally worth the headache and existential crisis. Number 6, proper time equation. You've heard of time zones, but have you considered time dilation? Because that's what happens when you mess with tau equals integral of the square root of 1 minus v squared over c squared. The time dilation equation from special relativity, or as I like to call it, why astronauts age slower and everyone else gets FOMO. This beauty comes from Einstein's theory of special relativity, which basically says the faster you move, the slower time goes for you. So if your twin hops on a rocket traveling near the speed of light and you stay home watching reruns, guess what? They'll return younger than you. Still hot, still smug, still younger. This isn't just sci-fi fantasy either, it's proven. GPS satellites have to adjust for this time dilation, or your map would think you're in the ocean when you're really in a parking lot. Time literally ticks differently up there. So yeah, time is not absolute. It stretches, it bends. It's basically the universe's most chaotic elastic band. And that's not even general relativity yet, that's special relativity. As in, just wait until the sequel. This equation flipped our understanding of the universe and ruined every movie plot that didn't account for it. But it also gave us a peek behind the curtain of how reality really works. Distorted, stretchy, and kind of rude. Number 7. Einstein's general relativity field equation. Let's wrap this countdown with a banger. Einstein's general relativity field equation. It goes something like r sub mu nu minus 1/2 g sub mu nu r equals 8 pig over c to the 4th times t sub mu nu. I know, sounds like you accidentally sat on a calculator, but hang tight. This equation is Einstein's way of saying gravity isn't a force, it's the shape of space and time. Yeah, he looked at Newton's apple and said, cute. But what if space-time is actually curving around massive objects and tricking us into thinking there's a force? In this equation, the left side describes the curvature of space-time. The right side tells us how matter and energy influence that curvature. It's like a cosmic feedback loop. Stuff tells space how to bend, and bent space tells stuff how to move. This is why black holes exist, why time slows down near massive planets, why light bends around stars. It's the reason GPS works, the reason your body has weight, and the reason that tiny planet in Interstellar had those annoying time-warping waves. Einstein turned gravity from apple falls down into space is doing gymnastics around mass. And suddenly the universe went from a flat stage to a bendy, twisty, constantly updating 4D dance floor. So yeah, this equation didn't just change physics, it changed how we even imagine reality. No big deal. That's all for today. I'll be making similar videos about science in the future. Subscribe to see them.